Hi, this is Jason Molesky. In this example, we'll take a look at analyzing the effects of transformations. During the winter months, the temperatures at the Starnes Colorado cabin can stay well below freezing. That's 32 degrees Fahrenheit or 0 degrees Celsius for weeks at a time. To prevent the pipes from freezing, Mrs. Starnes sets the thermostat at 50 degrees Fahrenheit. She also buys a digital thermometer that records the indoor temperature each night at midnight. Unfortunately, though, the thermometer is programmed to measure the temperature in degrees Celsius. Now, a dot plot numerical summaries of the midnight temperature readings for a 30-day period are shown here. We notice there's a bit of variability in the dot plot. We have a roughly symmetric distribution of temperatures over those 30 days. And also we have our summary statistics here, both the mean and standard deviation, about 8.43 degrees Celsius on average with a standard deviation of 2.27 degrees. And we also have our 5-number summary. Now let's use the fact that degrees Fahrenheit equals 9/5 times the degrees Celsius plus 32 to help answer the following. First, let's find the mean temperature in degrees Fahrenheit. Now, does this thermostat seem accurate? Well, to convert the temperature measurements from Celsius to Fahrenheit, we have our formula 9/5 times Celsius plus 32. Remember, multiplying observations by a constant also multiplies the mean by a constant. Also, adding a constant to each observation will increase the mean by that constant. So, the mean temperature in degrees Fahrenheit will be found by taking 9/5 times the mean in degrees Celsius, 8.43, plus that constant of 32, for 47.17 degrees Fahrenheit. Now, the thermostat doesn't seem to be very accurate. It's set at about 50 degrees, but the mean temperature, according to this, is about 47 degrees Fahrenheit. Now let's calculate the standard deviation of the temperature readings in degrees Fahrenheit and interpret that value in context. Now again, recall multiplying each observation by a constant would multiply the standard deviation by a constant, in this case 9/5. However, adding 32 to each observation will not affect the spread at all. So the standard deviation of the temperature measurements in degrees Fahrenheit is found by simply multiplying the standard deviation in degrees Celsius, 2.27, times 9/5, or 4.09 degrees Fahrenheit. So that means the typical distance of the temperature readings from the mean is about 4 degrees Fahrenheit. Now, suppose the 93rd percentile of the temperature readings was 12 degrees Celsius. What's the 93rd percentile temperature in degrees Fahrenheit? Both multiplying by a constant and adding a constant affect the value of the 93rd percentile. So to find that 93rd percentile in degrees Fahrenheit, we'll need to multiply the 93rd percentile in degrees Celsius by 9/5 and then add 32. Or in this case, 9/5 times the value 12, that was the 93rd percentile in degrees Celsius, plus 32, giving us 53.6 degrees Fahrenheit. Now for some additional practice analyzing the effects of transformations, try exercise 19.